Hello everyone. My name is Dr. Miss Nisha Kewat. I am an assistant professor in Sri Mallika Arjun College of Arts, Commerce and Sciences. Today's program is for Bachelor of Sciences, that is first year BSc. Subject is botany, that is generic elective. Semester 1. Paper code is BOG 101. Paper title is Environmental Biotechnology. Title of the unit is from Unit 3, that is Microbiology of Wastewater Treatment. Module name is Treatment Schemes for Wastewater of Dairy. Module number is 16. Outline: Treatment Scheme for Dairy Wastewaters. Learning Outcomes. At the end of this lecture, students will be able to list the causes for wastewater formation in dairy. They will also be able to describe the various processes for treatment of the wastewater in dairy. So now, this is a flowchart which says about the dairy industry. Dairy industry is one of the most water consuming industry among the food industry in the whole world. So, what is the reason for such a huge amount of water usage? Because the milk has to be processed by undergoing the various processing units such as pasteurization units, sterilization units, separation units, filtration units, and homogenization units. After undergoing all these processing units, we get a desired byproducts in the form of market milk, condensed milk, milk powder, cream, butter, cheese, curd, yogurt, ice cream, and many more. So, once the processing has been done, the industry is left with the huge amount of the dairy wastewater, which has a certain characteristics which, if it is not treated, will lead to a harmful effect onto the environment. In this slide, we see about the various characteristics of the dairy wastewater. First of all, it has a high carbohydrate content, which is specifically the lactose. Then they have a high protein, lipid, and a milk fat. They have a wide range of a pH, which ranges from the acidity and also to the basicity, that is 5.5 to 10.5. They also has a high COD, that is a chemical oxygen demand, plus they also have a high BOD, that is biological oxygen demand. In addition to 4, we have high dissolved solid, suspended solids. Secondly, since it is a milk, it has a lot of oil and a grease content, and also dairy industry is basically a not a sequential processing unit. Okay, in this there is in a dairy industry, processing is not basically a simultaneous, it is sequential. So one after the other processing units are followed. That's why there is a lot of a variation in the volume and also a lot of variation into the flow rate. Like one processing unit has finished the process, so it will discharge its wastewater. Then the second processing unit will be there, and then it will further discharge its wastewater. So what will happen? There will be a variation into the released wastewater. So the dairy wastewater has to be treated, and the main objectives of the dairy wastewater treatment are, first of all, to reduce the organic content, reduce the nutrient that will cause the pollution and the eutrophication, to remove and inactivate the potential pathogenic microorganisms which are inhibiting into the dairy wastewater. Then also come up and formulate specialized treatment to minimize the environmental problems. So this is the flow chart which tells you about the major grouping of the different types of the treatments which are employed in the dairy wastewater treatment. So first of all, it is majorly grouped as primary treatment and secondary treatment. Under the primary treatment, we have the mechanical treatment and chemical treatment. Under the secondary treatment, we have a biological treatment and physiochemical treatment. So, biological treatment are classified as anaerobic treatment and aerobic treatment. Physicochemical treatment are divided into coagulation, flocculation, adsorption, and membrane filtration process. So, this membrane filtration are further grouped into 4 types: First one is your microfiltration. The first one is a microfiltration. Second one is your ultrafiltration. Third one is your reverse osmosis. And the fourth one is your nanofiltration. Coming to the first type, it is a preliminary stage of a dairy wastewater treatment. So, in mechanical treatment, we make a use of a screen to remove the large floating material, remove the heavier organic matter by using the grit chamber. In a skimming tank, we remove the oil and a grease. And lastly, primary sedimentation tank or a clarifier allows the matter at a very low velocity to rest or settle down at the bottom of the sedimentation tank. So, once these all are done, collected material, okay, at the bottom is known as a sludge. And this sludge and effluent requires the further additional treatment so that it can be made into a harmless chemical treatment or precipitation. This is a precipitation of a dairy wastewater in which it is done by adding the flocculants and they are mixed vigorously. So they precipitate into an insoluble phosphate which aggregates as a fine particles and further aggregates into a larger flocks. These larger flocks settle down in the pre-sedimentation basins and they are referred as primary sludge. And clear effluent overflows into another basin for biological treatment. Then sedimentation basins are equipped with the devices that will scrape the sediment into the sump and oblique gutters that will carry off the water from the clarified surface layers. Coming to the physicochemical treatment, which is also referred as a precipitation, their major role is to destroy and reduce the milk fat, protein colloids, proteins, and grease which are obtained as a result of unskimmed milk production, separation of a milk and a whey. Whey is a liquid which is obtained after separating the curd. Then after separation of the cheese and a butter. So the precipitation of the protein and a fat is carried out by utilizing the following three methods. The first one is thermal coagulants, thermal calcicoagulation, chemical method. Coagulation and flocculation basically removes the suspended and solid particles. It greatly reduces the BOD, COD and also clears the turbidity of the wastewater. So, how the coagulants work? Coagulants, they destabilize the particulate matter which are suspended into the wastewater, which leads to the frequent collision of the particles. This further leads to the flock formation, first initially small, then later on larger flocks, and then once the larger flocks are heavier enough, they get into the sedimentation. Depending upon the nature of the coagulants, they can be of a chemical type, they can be synthetic type, and they can be a natural type. Chemical types are the ferric chloride, aluminum sulfate, calcium hydroxide. Talking about the synthetic ones, they are polyaluminum chloride, and the natural are the chitosan. Chitosans are basically naturally derived from the insect skins, that is, they are made up of the chitin. So, these are the different types of the coagulants. Once they are being, once these coagulants are being released into the dairy wastewater, coagulation takes place, and then after the coagulation, there is a activated charcoal treatment is given which eradicates the odor and the color of the wastewater and makes them suitable for drinking water. Now adsorption. Adsorption is very effective in the removal of the organic compounds in the wastewater, and for adsorption mostly activated carbon is used. In addition to the activated carbon, some other adsorbents can also be used such as rice husk ash, coal fly ash, etc. Sometimes these adsorbents can either be used individually or they can be used in a combination with other adsorbents such as powdered activated carbon, which is referred as a PAC, can be used with low cost adsorbents. The advantage of the PAC that is that it gives a better efficiency in reducing the content of the total solid content. Membrane treatment process. It is preferred to the higher degradation efficiency. It provides a better quality of the treated water, and it also controls the suspended solids. So, membrane treatment process is basically based upon the semi-permeable membrane, okay, that allows the movement of the certain compounds and also monitors the passage of other components. So, based upon the pressure, this membrane filtration process are divided into four types. First one is a microfiltration, which works on a low pressure, used for a bacterial reduction. Ultrafiltration, which operates with the medium pressure, is used for a decalcification of the permeates. Then we have a reverse osmosis, which works at a high pressure and it generates the water for reuse. Lastly, the nanofiltration, which is operated from medium to high pressure, and it removes the COD and nutrient, that is nitrogen and phosphorus. Biological treatment. There is aerobic treatment and anaerobic treatment. Aerobic treatment makes the use of the microorganisms which are capable of growing in a oxygen, whereas they use absence of the oxygen. Their main role, aerobic treatment, their major role is to degrade the organics to carbon dioxide and water, and their major role is to produce a biogas by degradation, okay, that is a methane and a carbon dioxide. Coming to the anaerobic biological treatment process, we have three types. That is upflow anaerobic sludge blanket, which removes the 90% of the COD. Then we have a hybrid digester, which used in a combination with the UASB with fixed bed designer, which removes 94 to 97% of the COD. Lastly, we have the anaerobic sequencing batch reactor, which removes the COD as well as BOD. This is the reference. Thank you.